Good evening. Yesterday we saw how to solve a system of linear equations graphically. Today we are going to solve systems of linear equations algebraically. Algebraically meaning I'm going to manipulate my equations mathematically and then figure out the values of x and y. So there are a lot of methods that we're going to learn. The first method that we're going to learn is called the substitution method. This is lesson 9.2. Substitution method, as the name suggests, to substitute means to replace. So I have two variables x and y. I'm going to replace one of the variables with a known value. It could be a numerical value or it could be a value as a variable, as an expression. So I'm going to use that expression for that variable in one of the equations and solve for one of the variables. Once I know one variable, I can figure out the other variable. So I know it's a little confusing, so let's straight away go to a problem. Say I have these two equations. This is a linear equation, this is also a linear equation. So I have y equal to 2x. This is my first equation. 2x plus 3y equal to 40. This is my second equation. Together, they make a system of linear equations. So I want to solve this equation algebraically, meaning I want to manipulate these two equations mathematically and then figure out what is the value of x and what is the value of y. So as the name suggests, I'm going to use the substitution method. So when I look closely into these two equations, my equation number 1 is telling me what y is. Even though it is not a number, it is telling me that y is 2x. So I'm going to use this information in my second equation and I'm going to replace my y with that 2x. So what I do is substitute the value for y equal to 2x, which you got from equation 1, into equation 2. So I'm going to put 1 in 2. So what do I mean by that? My second equation is 2x plus 3 times y equal to 40. So I know y is 2x, so I'm going to replace the y. So it is 3 times y is 2x. So I substituted, I replaced the y equal to 40. Now this becomes an equation in one variable now. So I don't have any y anymore. So I have to simplify this expression. So I get 2x plus 3 times 2x will give me 6x equal to 40. So now it is 8x is equal to 40. I can figure out what x is. X is 5. So I know the value for x. Now I have to figure out what y is. We know that y is 2x. So 2 times x. So x is 5. So I'm going to just plug in x equal to 5 in equation 1. Or equation 2. Since it's a solution to both equations, it has to satisfy both equations. So I either plug into equation 1 or plug into equation 2. Doesn't matter which one you plug in. So I got to plug in this value of x into equation 1. So y is equal to 2x. That means y equal to 2 times 5, which will give you 10. So y is 10. So I got a numerical value for both x and y. So my solution is 5, 10. The solution is 5, 10. Remember to verify your answer. So I need to verify the answer. meaning I need to plug into both equations and check if it works for both. So we just saw y equal to 2x, y is 10, x is 5. It works for both. Let's take a look at the second equation. 2x plus 3y equal to 40. X is 5. Y is 10. I want to know if this is true. So 2 times 5 is 10. 3 times 10 is 30. Equals 40. It works. So I verified my answer. So we started off with two equations. I used the information that I have in one of the equations in the other equation. So I substituted the value of y into the second equation and I got a single equation in x. And I solved for x, used that value of x to figure out y. So when they ask for a solution, I need to figure out both x and y. So please remember that. So let's take another problem. Let's take a look at this one. I have these two equations, negative 3x plus y equal to 1, 4x plus y equal to 8. This is equation number 1 and this is equation number 2. Both together form a system of linear equations. So as we look at our previous problem, one of the equations already told me what y was. Y was equal to 2x. It already told me that. But in these two equations, if I look at it, I don't see any equation that is telling me what y is or x is. I could tell you what x is also, but it's not telling me anything. But the beauty of it is, I see that y all alone. And here the y is also all alone. So I can really make it stand all alone by moving things over, right? So I could choose either one of the equations and make the y stand alone. So I take the equation 1. I'm going to rewrite and solve for y. Meaning I have this negative 3x plus y equal to 1. So I want to rewrite this equation in such a way that my y is standing alone. So how do I do that? Add the 3x, add the 3x. So I have y is equal to 3x plus 1. So let's say this is equation number 3. Meaning I took the equation number 1 and I rewrote it, made it look like something else, and I just say that is equation number 3. Now my equation number 3 is telling me what y is. Remember, equation 1 and equation 3, they are equivalent to each other. They are one and the same. Even though they look different, they are one and the same. So instead of using 1 and 2, I'm going to use 2 and 3 as a system and solve that system. So I have one equation which is y equal to 3x plus 1. I have the second equation 4x plus y equal to 8. This is equation number 2 as is. So now one of the equation is telling me what y is. Y is 3x plus 1. So I'm going to use that information and I'm going to plug it in, replace this y or substitute for this y. So I'm going to substitute equation 3 in equation 2. Okay, I'm going to substitute 3 into 2. So I have 4x plus, I always use a parenthesis while I substitute. So instead of y, I'm going to write it as 3x plus 1. So I have 3x plus 1 equal to 8. So this is 4x plus y equal to 8. Instead of y, I just replaced it or substituted it with 3x plus 1. Now I want to simplify this equation. 4x, this is just a positive sign that I'm distributing. So this will be plus 3x plus 1 equal to 8. So I have 4x plus 3x is 7x plus 1 equal to 8. Now this is a simple equation in variable x. So I can solve this equation to figure out the numerical value for x. So I subtract 1, so I got 7x equal to 7, or x is equal to 1. So I got my value for x. Now remember, it's not enough. I still have to figure out what y is. So I have different equations here. I have equation number 1, which is giving me the relationship between x and y. I have equation number 2, which is also giving me the relationship between x and y. I have equation number 3, which is also giving me relationship between x and y. Remember, the solution that we are finding is a solution that will make every single equation true. So if x is 1 for every equation. So I'm going to plug in the value of x in any one of the equation and figure out what y is. So we have the equation negative 3x plus y from equation 1. We know that negative 3x plus y is equal to 1. So I'm going to substitute the value of x into this equation. So negative 3 times 1 plus y is equal to 1. Negative 3 times 1 is negative 3 plus y equal to 1. I'm going to add the 3. So I got y equal to 4. So my solution is 1, 4. Remember, I still have to verify my answer. Verify the answer. I need to check if it works for my both equations that I started off with. So the first equation is negative 3x, so negative 3 times 1 plus y should be equal to 1. That is negative 3 plus 4. Is it equal to 1? Of course it is equal to 1. So it checks for my equation number 1. So let's check equation number 2. 4x plus y is equal to 8. So x is 1 and y is 4. Is it equal to 8? 4 plus 4 is equal to 8. It works. So it works for both my equations. So that means my solution 1, 4 is correct. So this is substitution. There are a lot of variations that we're going to look at. So this is the basic principle. So if you're familiar with this, it will be easier for us to proceed with the rest of the problems in class. So please practice this skill and try to focus on this problem, and then we will discuss much more in class. Thank you.